In this video, we're going to look at an improper integral that requires both a nice technique of integration and a technique for limits. So we're looking at negative infinity 0 of negative x e to the x dx. And first thing we do with any improper integral is turn it into a proper integral involving a limit. So limit, and I like to use a for the lower limit. You can really use any letter you want, just don't use whatever variable you're integrating over so you don't get confused. So I replace that, it's going to be a to 0. I'm going to go ahead and pull the negative out front and save it for the end so it doesn't get in the way. X e to the x dx. Now, this should look kind of familiar. It's not quite a u substitution. If this had been e to the x squared, we'd do a u sub, and that'd be fine. Basically, we're going to ignore the limit. Whatever you have to do to get this integral solved, you do. And this is going to be an integration by parts with u equal to x and dv equals e to the x dx. Then du is actually just 1 dx, and v is the antiderivative of e to the x, which is e to the x. So we can put this back together with our integration by parts. And so we do need to write the limit out front because we want it to always be true that it's equal. So we're looking at the negative limit as a goes to negative infinity. So whatever value we'll get, we'll just change the sign on it. And x e to the x from 0 to a to 0, excuse me, minus, it's uv minus v du, integral v du, the integral of from a to 0 of v du, a very nice, simple integral. Now, this part's all ready to go, so I'm going to go ahead and put in my limits there since it's ready to be done. So as a goes to negative infinity, so my first part is 0 e to the 0 minus, now putting in a e to the a, minus, now this integral, which is antiderivative of e to the x, is just e to the x, from a to 0. And let's see what kind of simplifying we can do. So negative of the limit as a goes to negative infinity. This part here is 0. So we're going to have negative a e to the a. And now we have to put in our limits for this guy, so I'll use parentheses for that. E to the 0 minus e to the a. Very common mistake with definite integrals. Don't forget e to the 0 is 1, not 0. Alright, so that's still going to be around. Alright, we have two parts that depend on a and one part that doesn't. We'll keep that negative out front until the very end. So negative. Now we're looking at the limit as a goes to negative infinity. So we're going to have to take the limit of this guy. So negative a e to the a minus 1 plus e to the a. And let's do this. Let's put the whole thing in parentheses for right now. Alright, we need to do these limits. Ignore this. These are the only two pieces that depend on a. The negative one is going to still be there at the end. We just have to figure out what's going on with each of these. Well, the graph of e to the x, just as a quick recall, is our exponentially increasing graph. But remember, we're looking at it as the input goes to negative infinity, so it goes to 0. So as a goes to negative infinity, this piece here goes to 0. This is going to go to negative 1. This is the only one we have to consider. So we need to look at this piece here. And what I'm going to do is I'm going to pull it off to the side so we can take a look at the limit as a goes to negative infinity of negative a e to the a. Alright. Now if I were just to plug in negative infinity, I get infinity times 0 from what we just looked at up here, which is an indeterminate form. It means we can rewrite it somehow to use LHopitals rule. So what I'm going to do is rewrite it, and so I got a to negative infinity. Easiest way to rewrite it is negative a over e to the negative a. Because now, as a goes to negative infinity, this goes to infinity. As a goes to negative infinity, because of that negative there, this also goes to infinity. This is an infinity over infinity case, which allows me to apply LHopitals' rule. Now, as a reminder, LHopitals' rule says I get to take the derivative of the top and bottom and recalculate the limit. Now I'm taking the derivative with respect to a, and you take them separately. I don't need a quotient rule or anything here. Derivative of negative a is negative 1. Derivative of e to the negative a is negative e to the negative a. Now if I like, I might want to go ahead and rewrite this to a positive exponent. The negatives you can see are going to cancel. So I get the limit as a goes to negative infinity of e to the a, which we've already seen is equal to 0. So this part here is also 0. The limit of a constant is a constant, so what we end up with is a negative 1 or a positive 1. So we can say this improper integral converges, and furthermore we can actually say it converges to positive 1.